Okay, let's dive into this one. You've probably seen it scrolling online somewhere. This like viral video shows a clear plate looks totally transparent, but you put it in front of something and poof, the object just vanishes. My first reaction was, "Whoa, okay, is this real invisibility finally?" Or maybe, some really slick stage magic or I don't know, digital effects. But what we want to do today in this deep dive is really unpack the optical engineering behind it because it's actually fascinating. It looks like plain old plastic, right? Or glass. But nope, it's this specially engineered thing, a lens array. And we've got our expert here to help us make sense of it, guide us through the science behind this, this vanishing act. So the big question, the paradox maybe, is how can something look clear, transparent, but also make things disappear? It's definitely not light just passing straight through.
It's pretty remarkable, isn't it? Yeah, your first instinct is just clear sheet of plastic, but that's kind of the core of the illusion. It's really not a simple window pane at all. What you're actually looking at is a very specifically engineered surface. Think tiny parallel ridges, usually molded from something clear like acrylic or polycarbonate. And these ridges function as what we call cylindrical lenses, or the broader term is lenticular lenses.
Lenticular lens. Okay,
Yeah.
so it's those little ridges, those grooves that are doing the work. It's not smooth at all then, up close. That's kind of wild.
Exactly. Those ridges are the whole secret. See, unlike let's say, a magnifying glass that curves in all directions, these are like tiny parallel cylinders or microscopic speed bumps. And they're designed very precisely to bend light, but only sideways, just along one axis. And this bending, this redirection of light as it goes through, that's refraction. Proper transparency means light goes straight through, unchanged, so you see what's behind. This thing, it actively steers the light instead.
Okay, so if the light isn't going straight, how does our brain deal with that? What do we actually see? Or I guess not see. Is it really just filling in the blanks?
That's a great way to put it, yeah. Filling in the blanks. The real cleverness is how your visual system reacts. So instead of light coming directly from the object behind the plate to your eyes, well, those little cylindrical lenses grab that light and shunt it off sideways, away from your direct line of sight. Your eyes end up getting light mostly from the sides of where the object is or from the background around it, but not from the object itself, right?
Okay.
And our brains, they're amazing pattern matchers. They see this gap, this missing information, and they basically paint over it
Yeah.
using the background information they're getting. Creates this really compelling illusion that there's nothing there, just the background. It's very sophisticated light control, really.
Ah, that makes perfect sense. That explains why in those videos, if you move your head just a little bit, the object suddenly pops back into view. You're moving out of that sweet spot where the light's being bent away from you. But are there times it wouldn't work so well? Like what if the object was, I don't know, bright red? Or the background was super complicated?
Yeah, you've hit on a really key limitation there. That shift in perspective, that
Yeah.
totally gives the game away. These lenses are usually optimized for viewing pretty much straight on. Move too far to the side, and the illusion breaks down. And your point about backgrounds and objects, spot on. The illusion is strongest when the background is fairly simple or uniform. That makes it easy for your brain to just kind of patch the hole, so to speak.
Okay.
If the object itself has a really complex pattern, or if the background behind it is very detailed and like totally different on the left versus the right side, the brain struggles. It can't make a clean fill. And, this is all passive technology too. No wires, no power.
Right, just the physics.
Just the physics of the lens shape. It's always on, always refracting light that way.
This whole idea, bending light to create illusions, it feels familiar. I mean, you mentioned privacy screens for laptops, maybe some stage magic, uses similar ideas. What other things use this kind of optical trick? Where else does this invisible plate idea fit in the bigger picture?
Well, connecting it to that bigger picture, yeah, the sort of light manipulation, it's definitely not new. Privacy filters are a perfect everyday example. They use tiny louvers or, yes, similar microlenses that just drastically narrow the viewing angle so you see it fine straight on.
But the person next to you on the plane just sees black. Yeah.
Exactly. Anyone off to the side gets nothing. And you definitely see related principles in stage illusions. Making things appear or disappear often involves carefully angled mirrors or other ways to bend light and fool the eye. And probably the most common one you see, those lenticular 3D posters or cards.
Oh, yeah. The ones that change image or look deep.
Yeah, precisely. Same basic tech. Arrays of cylindrical lenses showing you slightly different images depending on your angle, creating that depth or animation effect. What's really cool, I think, is how this Quite simple, passive tech can create such controlled visual effects, even now with all our digital stuff.
That's fascinating because, online, the hype around this plate, the invisibility shield thing,
Mm,
it can feel like we're this close to actual invisibility cloaks, right?
yeah.
Like out of sci-fi.
Yeah.
But you're saying maybe dial back the expectations. This isn't the Harry Potter cloak arriving tomorrow.
No. Slight chuckle. Not quite the Harry Potter cloak, unfortunately. And that touches on a really crucial point. Is it true invisibility? And the answer, pretty definitively, is no. It's a directional illusion, like we've been saying. It only works under very specific conditions. The right viewing angle, certain lighting. The background needs to cooperate, as we discussed. It's not some magic cloak that works from all angles in any environment, or actually makes light bend around an object perfectly. It's clever physics, absolutely, but it's definitely not magic.
Okay, so tempering the sci-fi dreams a bit. What does this mean for the future then? If this kind of passive optical engineering can pull off tricks like this, where could it actually lead? What are some realistic next steps?
Well, the potential for just controlling visual information, even with passive optics, is still pretty significant. You could see this sort of light-bending tech evolving into much more sophisticated materials, maybe dynamic privacy screens that aren't just on or off, but tunable.
Interesting.
Or thinking further out, it could play a role in making augmented reality or even holographic displays feel more integrated, more immersive. Imagine AR glasses that don't just overlay images, but could selectively block parts of the real-world view, making the virtual objects seem more solid, more there. The real power, I think, is in the elegance of it being passive. It shows how just tweaking the surface geometry of a material can fundamentally change how we perceive things, just by controlling where the light goes.
Wow. So what started as this kind of, wait, what? Viral video turns out to be some incredibly clever optical engineering. It's not true invisibility, we get that now. It's a directional illusion, right? Done with those tiny cylindrical lenticular lenses on the surface. It works because it bends light sideways, refracts away from your eyes, essentially. And your brain does the rest, filling in the gap, making the object seem to vanish.
Exactly. And if we connect that to the bigger picture, I think the key takeaway is just the sheer power you can get from passive optics. No batteries needed, no complex electronics. Just by shaping a surface in a very precise way, you can totally manipulate light and perception. It really is a master class in controlling light direction, an elegant solution that creates this powerful illusion, and it really highlights how much our perception depends on the path light takes to reach us. Sometimes the biggest insights come from understanding these fundamental physical principles.
So what does this all mean? Well, maybe that sometimes what you think you see, or in this case what you don't see, is really just a trick of the light, powered by some very precise, very cool physics. And maybe staying curious, asking, how does that work? Behind these things we see, that can reveal the real wonder, beyond just the initial kind of magical appearance. It's a neat reminder, isn't it, that our perceived reality can be surprisingly flexible, shaped by these unseen games of light and material.